Hello, welcome back to the stream. I was just feeling stressed about the whole of the world situation and stuff like that, and I was taking great comfort in playing Lemmings, which is a game I highly recommend you try out. But I just thought maybe someone would like a palate cleanser of, or maybe I would like a palate cleanser of me writing a program to reverse a string using test-driven development. So if that's you, Merry Christmas. Let's try and make ourselves a new project. I'm going to call it reverse. And let's see what we've got here. So let's write ourselves a test. So no, let's not download the latest Rust analyzer right now. So we'll have a module for our tests. And I think that's how you type that. Yeah. Okay, everything's coming away from me. So we're making a new test. Let's try reversing an empty string. Like so. So let's imagine there's a function called reverse, which takes in a string or a str. What does it take in? Does it return something or does it modify a thing? It modifies a thing. All right, so try again. So make a new string, reverse it, and the answer should be like, this is a bit, this is not great. Let's just, even though this looks bad, let's do string from da-da, and then we know that like it's equal to that, right? And it will match our other tests as well, which are going to look similar to this. Now we're imagining that a reverse function exists, but it doesn't exist yet. So let's make, let's have something happen in our main method as well. So, whoops, let's do, let's use this string. That'll be nice, wouldn't it? So we're going to reverse S. Now, that's not how you pass in a mutable reference to something, is it? Right, so let's pass in a mutable reference to S, reverse it, and print it out like this. So that's our main method, and the reverse function still doesn't exist, so let's create it. Like so. So it's going to take in... Well, I think it's going to take an immutable reference to... Well, can we take an immutable reference to a str? I guess we can. And it's going to return nothing at all. And here we need this to be mutable too. And we need to import it. And I normally just bring in everything from the parent module when I'm writing a test. So let's run our tests. And it failed because we hit a to do. So let's have our reverse function do absolutely nothing, and our first test should pass. Yes. And if we run it, it says hello world, which is wrong. So let's add another test. Let's reverse a string with only one letter in it. Let's say a single letter. So let's imagine we have a string containing the letter F. When we reverse it, it also comes out as F. So far our trivial tests are passing nicely. And we haven't yet found a problem with the interface I just designed. So let's do reversing two letters. FT should come out as TF. Test fails. All right, so we've got a failing test. Now, are we going to implement the entire reverse function just to make that test fail? Let's see. So how's this going to work? We're going to need to start at the beginning and start at the end of S. So I guess we can say, let's just say let the first iterator, let's say what is this? It starts at the beginning, it goes through the first half. Let's just call it I1. So it's going to be an iterator through S. So through the characters of S, like so. And it's going to be, thing is, it's going to be, we want it to be a mutating iterator. Chars and their positions, no. We want to be able to mutate. So is chars, can you mutate? Are we going to need to take a reference to a string? Can you mutate the things in a string? Let's find out. So this is going to be an iterator. No, it goes backwards. Reverses an iterator's direction. Yep. Okay, so we've got two iterators. And we're going to say that we're going to swap them. So can we do this? I'm not sure we can, but let's try. So this will be take I1 and I2 and put them into I2 and I1. And I don't mean let, I just mean that. So I1 and I2 are not mutable, so that is not going to work. How about that? You can't dereference iterators, you can just next them. So I guess this will be for now these could be .next, and we'll see what that actually returns as. Alright, so I can do test-driven development, but can I do Rust? It appears not. Alright, so this is not a reference. These chars are, and it's an iterator over chars. It's not an iterator over like references to the locations within the string. So we've got to immediately do something different. And what we're going to do is we're going to let the first index be 0 and the last index be the length of S minus 1. Now this feels really bad because this is, now we're going to be indexing into the strings. All right, so let's maybe make it faster later, or maybe not, because maybe we don't care. But now we can do S brackets I1 equals S brackets I2, but let's do that. Let's do our trick again. We'll see if it'll work. So let's say I2 I1 equals I1 I2. Gonna let me do that? No, because you can't index strings by characters. Yeah, we really want to be iterating through these strings because we want to iterate through the code points. Oh, you know what? This is so much harder than I thought it was because, all right. Okay. Oh, I thought it was going to be easy. Okay, so the final string that we end up with is going to be the same length in bytes as the string we started off with. But those characters might have all different lengths in UTF-8. So I think we can make ourselves a string. Like we're going to have to allocate the same amount of memory as the string to do this nicely. Like we could either assume it's all ASCII and do it horribly, and I don't want to do that. So let's make ourselves a temporary string. And I think we can say like with capacity, yeah. So we want it to have the same capacity as S. And then right at the end, we're just going to overwrite S with the temporary we made. And now we've got we can just go, okay, this is too easy. Because now we can just go through the characters in reverse. So iterate through S, reverse that, and for each one, we will push J. So we're going backwards through S, that should be chars. We're going backwards through the code points in S and pushing each of them into temp. What if we did like that? Or this, maybe? Maybe there's a better way of doing that. Astra, maybe as mutstra. So I guess why are we it's not mutable, it needs to be mutable anyway, so that's fine. How's this? S is a mutable reference to str. Yeah, something is not quite... I think maybe S needs to be a reference to a string. Whoops. And then this will work. And now it would just be S equals temp, right? No, star S equals temp maybe. There we go. All right, so now let's just try a mutable reference to a str. And this will be astra, maybe. Or maybe it should be, now it should be star temp. There must be something we can do here. No, you can't dereference S. It's a reference to a str. But maybe we could do something with S, because it's a mutable str. So can we like replace all the characters of S somehow? Probably not. Like it's mutable, so I think that means we can modify the bits in it. Replace. No, that replaces characters which match a pattern. I mean, it's already mutable, right? So I don't think we want as mute. Maybe we want deref. What does that do? Is that different from star? I'm going to stop messing about with this soon. But I did make it... I did make it too easy, so now I'm making it harder for myself. Okay, so it feels to me like if you want to mutate... The way that I can think of to mutate S is to make it a mutable reference to a string. And then we can say, replace it with this new string we've made. And then it works. Well, we don't know if it works because we haven't run our tests. Our tests pass. Okay, so, and actually all of our difficult tests are going to pass. So first of all, let's do a test with a bunch more ASCII characters. And this should come out as FEDCBA, right? No, reversing longer ASCII. Reversing ASCII. Just reversing ASCII. Fine. All right, and also our next test is going to be So we maybe should have written these tests before we made it all work, but we didn't know at the time whether our first implementation was going to be one that did everything. But now we do. So I don't really like putting non-ASCII into my source files, but I will in this case. So let's just use the name of my friend. This is definitely not that character is definitely more than 1 byte in UTF-8, so it should still work. Yeah, okay, so now we've done something difficult here, right? So this string consists of a 1 byte character, then a 2 byte character, I assume, or at least more than one, and then another 1 byte character, another 1 byte character. And we have now returned a string which has a different pattern of 1 and 2 byte characters. So the way I was initially thinking about doing this, which is to go through swapping characters in place, will not work for a string. But it might be interesting to think about how that would work if we definitely only had single bytes. If we had not a string, but some kind of thing. So imagine we had something like this that took in a mutable slice of U8s. Because the point is, we've had to make a new string to do this. But if we've got a mutable slice of U8s, we ought to be able to do something nice with just swapping over the bytes without doing anything difficult. So let's make ourselves some new tests. We'll put them at the top just so that we're not scrolling around too much. And let's call this reverse bytes, I guess. Make ourselves a test. In fact, let's have all the same tests. But instead of having characters in there, we'll have something else. So reversing an empty bytes, reversing a single byte, reversing 2 bytes. So this is just, I'm doing this because this is how I was imagining I was going to implement it before I realized this would be reversing a longer bytes. And I think that's, well, I guess we could do odd and even, couldn't we? Reversing longer bytes, odd. And this one can be reversing longer bytes, even. So this would be, well, let's have it be a vec. Should we have a vec or a, let's have a vec. It's the way you would probably end up using it, isn't it? So imagine we've got a vec of bytes, which is empty. And then we reverse it. Then it should come out as an empty vec. By the way, loving the fact that the vec macro can be an empty vec these days. All right, now let's write out this test as well while we're here. So let's have a vec which has got, hold on, that was supposed to be a single byte, and here I'm doing an empty one. So should have done that here. So empty single byte, let's just have the number 6. And then 2 bytes, well, let's have the numbers 7 and 8. Well, no, 7 and 81, just for, just for, like, making sure they're not, it doesn't only work for numbers under 10. And this should be reverse bytes. So you've seen 2 patterns there. One where I didn't write enough tests up front, and one where I've written too many tests up front. So why isn't it like this? Oh, I missed the semicolon. Okay, so then we've got an odd number of bytes. That's an odd number. And this should be reverse bytes. And I guess we'll copy that and do it even with just 4 of them. Well, let's do 6 just in case 4 is not quite enough to make something go wrong. And obviously this one should be 12, 4, 6, 81, 7. And this one should be similar. 4, 6, 81, 7. Alright, so how many of our tests are going to pass so far? Well, some things are not working because this should have been reverse bytes. We've got a warning. We've got some failing tests. 3 failing tests, all the ones that do stuff. All right, so now let's see whether we can do a clever implementation. We're probably going to have to use pointers, which I've not used before, but let's start with iterators and see how we get on. So let the first iterator be an iterator through these bytes. I guess a mutable iterator. Now this is where we're going to hit a problem. And the second iterator also be a mutable iterator through the bytes, reversed, and then obviously immediately, when we use them. So now all we want to do is swap the first one and the second one. So what is it? It's iterators can be nexted. So we're going to need to next each of them, which will give us the first byte or a reference to the first byte. So this is an iterator over a mutable reference to a U8. So we're going to next each of them. So let's just say like value 1 is iterator 1.next, and value 2 is iterator 2.next. Sometime soon it's going to tell me you can't have 2 mutable iterators. First of all, these need to be mutable. Now you can't take a second. Mutable iterator over bytes. So instead of that, I guess we're going to need to use pointers and some unsafe stuff. Let's finish. Shall we finish? No. All right. So how do I get a pointer to the beginning of bytes? I guess I can say, can I cast an mutable iterator to a pointer? No, I need a reference. So I guess I'll say, give me the first byte. Give me a reference to the first byte, and I want to say that it is a mutable pointer to a U8. I think that's how you write that. Maybe if I mute it. Yeah. Okay. So what I've done is I've taken a reference to the first byte, first thing in bytes. But I've said that the type is a mutable pointer instead of a mutable reference, and Rust knows that it can coerce that. I think coerce is the right word. So let's have a mutable pointer to the last byte as well. So mutable reference to the last thing that's in bytes. Now I think what I want to do is what I was writing a while ago, which is that I want to swap these two. I still don't know whether I can actually do this swapping like this, but we'll see. Like so, swap them. But this whole thing needs to be in an unsafe block. All right, so maybe those don't need to be mutable. Oh, they will be later anyway. So, all right, so unsafe. And we're going to write a safety comment. So what's the safety comment? Safety. I1 is within bytes because we set it to the first byte of bytes. We've already found a problem, which it is. It might not be within bytes because bytes might be empty. So writing our safety comment helped us, didn't it? So if, I guess we can say, if bytes is less than, or if bytes is empty, I guess. If bytes is empty, return. Maybe we don't need that because we've got to check something else as well. So I1 is within bytes because we set it to the first byte of bytes. That's the first piece of safety. But the second thing we need to say is, and I2 is not equal to I1. Otherwise we're really, like, what's going to happen? It feels like that could be undefined behavior. So let's say, which I think might be undefined behavior. Which I think, because we're assigning something that we're also reading from, which I think might be undefined behavior. But I don't actually know that for sure. So just writing out all of my thinking here. The reason they're not equal is because we've just checked it, which I'm about to implement. We haven't yet checked it because we've just checked it. So if I1 equals I2, return. But it's not even that. It's if I1 is greater than or equal to I2. Return. Which I kind of think means we don't need this check. Because, no, but this I2 is not even a valid thing, right? But I think that's okay, as long as we don't read from I2. If it's less, so if I2 it starts out being less than I1, we'll immediately return. So we don't need this. So I1 is within bytes because we set it to the first byte of bytes. And if bytes is empty, I2 will be less than I1. So we don't get here. I2 is not equal to I1 because we just checked it. Fine. I think our safety comment is covered. These don't need to be mutable. Reverse bytes is not used. Let's use it. Here. So let's have a vec with some stuff in. You know what? We haven't ever run the other program. We should do that. Reverse bytes B. And then we should be able to just print out like it's debug print of B. Hopefully. And let's just cargo run. So we got some warnings, but look, hello world did get printed out backwards, but, oh, and look, in our case, our thing wasn't long enough and something got printed, but it's not the correct. Let's just do these in order, shall we? 1, 2, 3, 4, 5, 6, 7, 8. So when we try and reverse those bytes, they're not yet reversed. The 8 and the 1 are swapped, but the others are not because that's all we've implemented. All right. So our program is at least not crashing. So it might be safe. I don't know. And some of our tests are passing and some of them are failing. So 3 are failing. The long ones and empty. The empty one failed. Oh, it panicked because you're not allowed to do this. So we actually did need this thing. All right, so now we can change our safety. And we checked it's not empty. Oops. So I think that makes it just a bit simpler. All right, so only 2 tests failed now. And we've still got a warning. So our tests that check that it really does what it's supposed to do worked. All right, so how do you reverse a string? Well, if it's a string of just bytes and you know exactly their size, how you reverse them is you take a pointer to the beginning, pointer to the end, and you loop through, increasing the first one, decreasing the second one, until they clash, and until they get loop past each other. See what I mean? So we loop, we break out if we're at where we have the 2 pointers have overlapped past each other. We swap the characters if not, and then we move them on. So I1 needs to move forward 1, and I2 needs to move backwards 1. Right? And you can't move pointers using plus. So do you have to do add? What does add do? Adds an unsigned offset to a pointer. This can only move the pointer forward or not move it. If you need to move forward or backward, depending on the value, you might want to offset. All right. So why would we use wrapping add? I mean, okay, let's just try add. And these might be unsafe as well. So we might need to justify. So sub, I guess, would be to move backwards. Surely. No, those won't be unsafe, will they? No, they are unsafe. Okay. So let's do these as separate unsafe blocks with our own safety comments. Okay, so this will be safety. Hang on. What are the safety criteria here? Safety. If any of the following conditions are violated, the result is undefined behavior. The result must fit into an I size. Fine. If the computer offset is non-zero, self must be derived from a pointer to some allocated object. The entire memory range between self and the result must be inbound to that allocated object. Particularly, this range must not wrap around the edge of the address space. Okay. Computer offset is non-zero. Self must be derived from a pointer to some allocated object, and the entire memory range between self and the result must be the bounds of that allocated object. Okay. Allocated objects can never be larger than I size max, so if the computer offset stays in bounds of the allocated object, it's guaranteed to satisfy the first requirement. Okay, that makes sense. So it's got to be inside some memory that was allocated for that object. And then it's talking about something that we actually did, which is, we should use as putter here, shouldn't we, instead of, I guess, but anyway. So what they're about to say, this implies, for instance, that if you add on the length of a vector, is always, so this says it's always safe. Consider using wrapping add if these constraints are difficult to satisfy. Okay, I wonder what wrapping add does then. Does it wrap around inside the allocated object? Because that would be bad if that fooled me in some way. We want it to be super fast so we can use aggressive compiler optimizations. Okay. So let's have a quick look at what wrapping add says. This is going to be a super quick video. All right. Adds an unsigned offset to a pointer using wrapping arithmetic. This operation is always safe, but using the resulting pointer is not. The resulting pointer remembers the allocated object that self points to. It must not be used to read or write other allocated objects. Fine, yeah, I won't do that. Fine. Yeah, you got to use pointers. Well, all I'm doing to these pointers is dereferencing them, so we're not doing anything strange here. All right, so compared to add, this method basically delays the requirement of staying within the same allocated object. Adds immediate undefined behavior when crossing the boundaries. Wrapping ahead produces a pointer, but still leads to undefined behavior if the pointer is dereferenced when it's out of bounds of the object it's attached to. All right, then we're going to use add, and we're going to justify that it's all okay by saying we're going to stay within the bounds of bytes. So I plus 1 is either within the bounds of bytes or 1 past, which is allowed. If I read that documentation right, 1 past the end, which is allowed. Which is allowed. We know this because I2 pointed at the last byte and only ever got smaller, and I1 is greater than, no, less than I2. Okay, so I1 plus 1 is either within the bounds of bytes or 1 past the end, because I2 started off as the last byte and I1 is less than I2. Fine. I think that makes sense. Does that make sense? And what about this? This is like the first unsafe code I've written other than like example. This is just a silly example too. So I2 minus 1 is either, hang on, within the bounds of bytes. It's got to be within the bounds of bytes. Is it? Within the bounds of bytes, because it started off at pointing at the last entry, and it is greater than I2, and I2 is greater than I1, and I1 is greater than, and I1 is at or before. Let me get this right. So I2 is got to be, I2 can't be pointing at the first one. So it's at or after the start of bytes. So does that make sense? I2 minus 1 is within the bounds of bytes because it started off pointing at the last entry, and it's greater than I1, and I1 is either the first one or after the first one. So I2 can't be pointing at the first one. In particular, I2 cannot be at the start of bytes. So it is safe to decrement it. Right, that does make sense. That is right. All right, so why is it moaning at me? All right, it returns a new pointer. So we have to say I1 equals I1.add1, I guess, like that. No, it should be I1, not star I1. We're not modifying the thing that I1 points at. We're modifying I1 itself. Okay. So I think that's the implementation. Let's try it. If it passes our tests, it does. And we run it and it reverses our string of bytes. Then it looks all right to me. And I'm pretty happy with our safety. So goodness me, this is simpler in C. I mean, it's worse in C as well. But yeah, okay. So if bytes is empty, bail out. There's nothing to do. If bytes has one thing in it, then we carry on to here and we say that I1 should be the beginning of bytes. I think we saw that we could say as putter here. Yeah. As mute putter. Like this. And can we do some kind of as mute putter? I guess that I2 can be I1 dot add bytes.len, right? We saw that in the example. But now we'll need a safety comment. But that looks cheaper. Looks like this will be marginally faster, so it's well worth the unsafety, right? For our game we're playing. So safety. Hold on. We shouldn't be adding len. We should be adding len -1. But hold on. That means we can't be. All right. So first of all, we can't be adding -1. So this is. So what do we want to say? I2. Hang on, we've got to do this. Like that. Semicolon at the end. Yeah. So, safety. Well, what we've got to say about this? We've got to say that it's going to stay within. So bytes.len -1 produces a pointer that is within. So I guess it's. Moving on. Bytes.len -1 from the start. Produces a pointer that is within the bounds of bytes. Because it is specifically it points at the last item within bytes. Bytes.len. Well, I guess we don't pass a negative number to add because bytes is not empty, because we just checked and bytes is not empty. All right, run the tests. Still works. All right, so even faster. Look how fast this code is now. We check whether bytes is empty. We get a mutable pointer to the beginning of bytes. We get a mutable pointer that points at the last thing in bytes. So not the end, but because the end is like after the last thing. We're pointing at the last thing in bytes. That's why we've got the -1 here. And then we loop through. If they've already overlapped, which could have happened immediately, right? Like if the length of this is only 1, then I2 is pointing at the first thing in bytes. Because the first thing is the last thing in bytes. And I1 is also pointing at the first thing in bytes. So they're equal, so we'll immediately return. So therefore, like at this point, we know that bytes is longer than 1. and we swap over. We say the thing at I2 becomes the thing at I1, and the thing at I1 becomes the thing at I2. So we swap the two things, beginning and end. Then we add one to I1. We take one away from I2, and we repeat until they either become equal or have overlapped each other. And that's why I had the odd and the even tests there for those two cases that they might become the same. Like, so for example, if we break this and say, get it wrong, then some of our tests will fail, right? No. Oh, no. Oh, gosh. That feels like it might be undefined behavior, though. So, yeah, okay. Can we test for that? Probably not. So we let I1 and I2 become equal, and then we swapped I1 with I2 here. And yeah, which is why I've got this comment here saying I think that might be undefined behavior, but we might have just got away with it. I just don't know. Maybe you're allowed. Maybe you're allowed to swap a memory location with itself. I mean, I'm not 100% clear that this pattern here is okay. Maybe we needed to make some kind of temporary variable. I bet there's some cool safety checking stuff you can run over your Rust code that will check whether this is undefined behavior itself. I don't know. I mean, it's kind of idiomatic to say swap them by this, so maybe it's fine. Maybe someone would have checked. Should have looked up. Didn't know I was even going to do unsafe when I sat down to do this video. There you go. So then we've had a little lesson in weird unsafe code in Rust. We've got a load of tests. All right. So we've already gone on about the safety of it. So it's all fine. Now there must be a reverse function on a string, right? Oh, needed a semicolon all along. So that same again. S dot reverse, right? Reversed. How do you reverse a string? Maybe there is no. I mean, you've got it is a one-liner to say s.chars.rev.collect, right? And then print it out. Is that right? Something like that? That seems happy with that. Yeah, okay. So here's your quick answer of how to reverse a string in Rust, just in case you were tempted to copy this code or something like that. So that means, I guess, we can also replace the implementation here. It still will make a temporary string, I think, but let's just... This should be the same as that. So... But I guess that just felt too easy. Doesn't like that. Oh, I guess because S. No, yeah. Should it be? Yeah. Maybe that. All right. Does that work? Yeah. Okay. So we can replace our initial function with just a one-liner, which says replace S with the result of iterating through the characters of S, reversing that iterator, and then collecting that, and it knows the type that it should collect into because basically it's the type of whatever S dereferences to. Now, can we do something similar for reverse bytes? I mean, I like my implementation, right? So I don't want it to go away, so I'll just comment it out. But I guess so the point is, the efficiency here, in order to collect, it has to, I think, allocate a string, put all the data in there, and then replace S with that string. So we're going to get a similar implementation here if we say star bytes equals bytes. iter rev. So the key thing here is, and then collect. Something like that. It won't know what to collect it into, right? So if we tell it what to collect into, will that help it? I think this might be doomed. Collect them into a vec, please. So we expected a slice of U8, and we had a vec. So what if I did something like that? It's not going to be happy. No, it doesn't like it because we had to use a string here. So this would have to take in a vec of U8. Then we could do this. And it would have exactly the same logic as this. It would have to build a vec and then replace the vec we've been passed in with it. So we won't do that. Now, what's the efficiency? We know the efficiency of this is really good. We don't allocate any new vector or anything. We're given a mutable slice and we just modify the bytes inside that slice. But the price we paid for that was a whole load of unsafety and a whole load of me waffling on about how it's probably fine, including still actually not knowing whether this is fine to do or not. Whereas there's no unsafety here, but there is some inefficiency here. Basically, the inefficiency is we're going to allocate a string. Now, I would expect that this can preserve the information about how long the string is through this chain of stuff. It's even possible that somehow the machine code of this ends up... No, it's never going to look like this because of the different lengths. But it's possible that the machine code... Yeah, I would expect that this is going to get turned into allocate me a string of the correct length. So we won't have to like grow it dynamically, but I don't know for sure. So we did it manually before with our previous implementation. So maybe we're a bit happier with this, where we allocated temp and we pushed in the characters individually. Yeah, it would be interesting to run that through Godbolt and see whether it comes up with the same code for these two different cases. All right. Anyway, that got way deeper than I expected it to be. I thought it was going to be a tiny little video where we just reversed a string, but it turned into a video where we reversed a string, and strings are always more complicated than you think they are. And then we found something simpler and reversed that in the most complicated way we could think of. Hope you enjoyed. See you next time.